It's common for faculty members from other universities to visit our department and even spend a few months here. Dr. Victor Homar is doing just that. He's from the physics department at the University of the Balearic Islands in Spain on the island of Mallorca in the Mediterranean Sea. Welcome to Penn State, Victor.
Well, thank you very much. Pleasure to be here.
Why don't we start with simply your motivation for being here? Why are you visiting the Department of Meteorology?
Well, visiting the Department of Meteorology here, it's a pleasure and it's an honor for me. I'm here because here you have a great faculty. You have faculty with a wide range of expertise. And as a graduate student, I was using one of the models that was developed here, and it was, for me, referring to that model was putting MM5 from Penn State. So this was like a sacred place that I never got to know, and here really it's an honor to be here to interact, and it's a natural place, natural environment for me to collaborate and to interact.
Yeah, and indeed, the department is well known for its development in numerical models. Now here in the United States, when we say severe weather, it has a formal definition: large hail, damaging winds, or tornado. Give us your perspective of severe weather as someone who studies weather in and around the Mediterranean.
Right. This is very interesting. Severe weather happens all over the world. And in the Mediterranean, we, of course, have severe weather as the one you have here: tornadoes, hail, and strong winds. But our number one threat is flood. Floods are the atmospheric phenomena that produce most damages and most threat to life. And one of the systems that we are recently analyzing are one type of cyclone that's produced in the Mediterranean that produce severe weather, and those cyclones are called medicanes, and we lately are very strong on studying this kind of systems that produce severe weather.
So medicane, sort of a play on the word hurricane. So how rare are these storms? How big do they get?
Well, these are fairly uncommon. These are fairly rare. We have between 1 and 2 events per 2 years. Every 2 years we get 1 or 2, and these are fairly small in size. We get sizes between 100 and no larger than 300 kilometers. They don't get really intense as the hurricanes because we have much less energy in the Mediterranean. So they get up to level 2, about 100 miles per hour winds. But they produce strong precipitation, very heavy precipitation, and it's one of the main subjects of study that we're working on recently.
Right. So here in the U.S., I mean, we're used to hurricanes coming out of the tropics into the mid-latitudes, and then they transition to non-tropical, sort of regular storms. But things are a little bit different when it comes to medicanes, right?
Right. This is very interesting because, as you said, hurricanes used to transition to extratropical cyclones. Medicanes, although we are continually studying them, what we know for the moment is that they happen to just transition the other way around. They need first a prior, what we call a baroclinic, which means a trough coming from the Atlantic to the Mediterranean. They produce a cyclone over the Mediterranean, and then that cyclone kind of transitions from extratropical to tropical characteristics. And now we're trying to understand why that happened and when that happens.
So it's the exact opposite, more or less, of what we observe with hurricanes.
Right.
So you're also very interested in numerical weather prediction, computer modeling. What are some of the unique challenges of numerical weather prediction in and around the Mediterranean?
Right. The Mediterranean is an area, it's a very interesting area with 150 million people living all around the basin. And so we have what we would call an explosive combination for the weather forecast to go wrong. We have densely populated areas. We have an area with very few observations in situ. And then we have the typical chaotic nature of the models, that it's everywhere in the world. So it's a big challenge due to the geographical characteristics of that area.
Yeah, so we often think here the Mediterranean is just a tourist destination, but it's actually very densely populated. Well, why don't we finish up? You're currently involved in a 10-year project. Let me get this right. It's called HYMEX, Hydrologic Cycle in the Mediterranean Experiment. What's the primary goal of that field experiment?
Right, the goal of that experiment is to analyze high-impact weather in a seamless way, from very short time ranges to climatic change ranges. So we're trying to understand the whole water cycle, and atmospheric people, oceanographic people, hydrological people are involved. And that's a very important effort because it brings together different disciplines, and one of the most important is that there is a coordinated effort between different countries, which is not easy in that part of the world.
Understood. Dr. Victor Homar, thanks for stopping by while you're visiting the department.
Thank you. A pleasure. Great pleasure. Thank you.
We'll be back in a moment with a recap of the short-range forecast.